The quotient rule says that when we have a function divided by a function, then its derivative is going to equal to the function g times the derivative of the function f minus the function f times the derivative of the function g all over the function g squared. An easier way to remember this is to say that the derivative of a fraction high over low is going to equal to low d high minus high d low bottom squared, and off you go. And when we say and off you go, once we use the quotient rule, we have to simplify the derivative. So this is saying that the derivative is going to equal to the bottom function times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And a thing to note is that sometimes we have things like 1 over x and we have to find a derivative. Well, we could use the quotient rule to find a derivative, but an easier way is to just rewrite this as being x to the negative first power, and then all we have to do is use the power rule to find the derivative. And then other times we also can have e to the x divided by x, and then similarly we can rewrite this as being e to the x times x to the negative first, and then we'll have to use the product rule instead of the quotient rule to differentiate this, which should be a little bit easier. And then other times we can have e to the x over x plus 1, and we can also rewrite this as e to the x times x plus 1 to the negative first power. And then we would use the product rule and the chain rule. So even though here when we rewrite this one we avoid using the quotient rule, now we have to use the product rule and the chain rule, and it'll actually be messier. So the thing to keep in mind is that sometimes it's easier to just rewrite certain expressions in terms of negative powers or in terms of a negative power times a function, but other times when we rewrite expressions like this, it actually makes it messier to differentiate. So let's look at an example. We're asked to differentiate y is equal to e to the x over x squared using the quotient rule. Because once again, we can avoid using the quotient rule by rewriting this as e to the x times x to the negative second power, which might be easier to solve, but we're going to go ahead and differentiate using the quotient rule. So using the quotient rule, the derivative y prime is going to equal to low d high, so the derivative of e to the x is e to the x, minus high e to the x, d low, derivative of x squared is 2 to the x, bottom squared, x squared, squared, and off we go. So now we simplify the derivative. So looking at it, we see we can factor out an e to the x from both terms in the numerator. So we'll go ahead and do that. So this is equal to e to the x times x squared minus 2x divided by x squared raised to the second power is the same thing as x to the 2 times 2, which is x to the fourth. And then we can also factor out an x. So we'll go ahead and factor out an x, giving us e to the x times x minus 2 over x to the fourth. And then we see that we can make a cancellation. We have an x in the numerator, and then we'll take one from the denominator, which will finally give us e to the x times x minus 2 divided by x to the third power. And this is the simplified derivative. Alright, let's look at another one. So this next one is asking us to find the derivative of x squared minus 4x over x to the third plus 2. So here we have d dx, the derivative with respect to x. This is a differential operator. And all this is saying is take the derivative of whatever is inside. So we're going to go ahead and do that. We're going to use the quotient rule because we see that we have a function divided by a function. So using the quotient rule, the derivative is going to equal to low x to the third plus 2 d high, the derivative of x squared minus 4x is 2x minus 4 minus high x squared minus 4x d low, the derivative of x cubed plus 2 is 3x squared bottom squared, and off we go. So now we simplify. So before we simplify this derivative, a quick note to make is that when we have our bottom squared part, we don't want to expand it, especially if it's a binomial. So we don't want to expand, because expanding this will take a lot of work and it won't really help us. So we're going to go ahead and leave this alone. So we're going to FOIL the numerator and then distribute these two, which will give us 2x to the fourth minus 4x to the third plus 4x minus 8 minus the product of these two terms. So when we distribute this 3 times x squared, we get 3x to the fourth minus 12x cubed all over x cubed plus 2 squared. We'll go ahead and distribute this negative sign, which will give us 2x to the fourth minus 4x to the third plus 4x minus 8 minus 3x to the fourth plus 12x to the third, because we have a double negative, all over our denominator of x to the third plus 2 squared. And then we'll look for common terms to combine. So we see that we have a x to the fourth here, we have an x to the fourth here, we got a x to the third and another x to the third. So we'll go ahead and combine those, which will give us 2x to the fourth minus 3x to the fourth will give us negative x to the fourth, a positive 8x to the third, and then our 4x, and then our negative 8, all over x to the third plus 2 squared. And that's it. This is the simplified derivative. Alright, let's do one more that involves trig functions. So let's say that y is equal to sine x divided by 1 plus cosine x. So once again, we see we have a function over a function. We'll go ahead and use the quotient rule. So using the quotient rule, the derivative y prime is going to equal to low 1 plus cosine x, d high, the derivative of sine x is cosine x, minus high sine x, d low, the derivative of 1 is 0, the derivative of cosine x is negative sine x, so that'll just give us a negative sine x. Bottom squared, and off we go. So now we simplify. So we'll go ahead and distribute this cosine x and then combine these two sine x's, which will give us cosine x plus cosine squared x plus, because we have a negative and a negative, plus sine squared x, all over 1 plus cosine x squared. And then we notice that we have a cosine squared x plus sine squared x. And we know from trigonometry that this is an identity. We know that cosine squared x plus sine squared x is equal to 1. So using this identity, we're going to go ahead and rewrite this whole expression. We're going to say that cosine x plus 1 over 1 plus cosine x squared. And we see that we can actually cancel out a term from the top and the bottom, because cosine plus 1 is the same thing as 1 plus cosine, and we have a product of 2 of them in the denominator. So we'll go ahead and cancel out a cosine x plus 1. It's going to give us a 1 in the numerator and 1 plus cosine x term left in the denominator. So we get 1 over 1 plus cosine x. So once again, earlier we said that it's better to just leave the denominator squared alone. And here is one reason why we do that, is because sometimes we can actually make a cancellation. And that's it. This is the simplified derivative.